we have to find the dimensions of displacement gradient. We have to find the dimensions of displacement gradient. We know that displacement gradient is rate of change of displacement with respect to distance. Displacement gradient is equal to delta x by delta x, where delta x is the change in displacement. Hence we can say that displacement gradient is the rate of change in displacement with respect to distance. Now we have to find the dimensions of displacement gradient. Dimensions of displacement gradient equal dimension displacement gradient equal dimension of delta x divided by dimension of delta x. Now dimension of delta x is L, capital L by capital L. So finally we get the dimensions of displacement gradient as dimensions of displacement gradient equal 1. That means displacement gradient is a dimensionless quantity. Displacement gradient is a dimensionless quantity. Number 17, that is next topic, we have to find the dimension of strain. For that we have to draw a diagram of cylindrical wire which has initial length L1. L1 is the initial length of this cylindrical wire. L1 is the length of this cylindrical wire, and a deforming force F. Is applied normally to the area of cross section of the wire. F is the deforming force which is applied normally to the area of cross section of the cylindrical wire. F is the deforming force, and due to application of deforming force, length of the wire will increase. Due to application of this deforming force, length of the wire increases to L2. Here the length will be the wire will be elongated and becomes thin, and length of the wire becomes L2. Final length of the wire becomes L2, and deforming force F continues to act towards right. Deforming force F continues to act towards right, and restoring force Fr comes into play in the opposite direction of deforming force. Here restoring force acts towards left. And due to this restoring force, the elongated wire will regain its initial length after removal of deforming force, and we can denote increase in length, that is change in length of the wire. Here delta L is the increase in length of the wire. Here longitudinal strain. Here this strain is related to change in length. That's why it is called longitudinal strain. Longitudinal strain is the ratio of change in length and initial length of the wire. Longitudinal strain equal change in length divided by initial length of the wire. Therefore longitudinal strain equal delta L divided by L1. Now you have to find the dimensions of longitudinal strain. So this is the expression of longitudinal strain, which is delta L by L1. Therefore dimensions of longitudinal strain equal dimensions of delta L divided by dimension of L1, where delta L is change in length or increase in length, and L1 is the initial length. Now dimension of delta L is L, dimension of initial length L1 is also L. Dimension of initial length L1 is also capital L. So finally we get the dimensions of longitudinal strain. Dimensions of longitudinal strain equal 1. Under bracket we can write dimensionless. That means longitudinal strain has no dimension, or longitudinal strain is a dimensionless quantity. Dimensionless. Now you have to find the dimensions of relative density. Relative density is rho r, which is the ratio of rho and rho w. That means rho is the density. Rho is the density of a substance. Rho is the density of a substance, and rho w is the density of pure water. Rho w. Rho subscript w is the density of pure water. So we get the expression of relative density of a substance, that is rho r is equal to rho by rho w. Now dimensions rho r will be what? What will be the dimensions of relative density rho r? Dimensions of relative density rho r will be what? 1, that is dimensionless quantity. Dimension of rho r will be 1, or dimensionless quantity. In what way it will come as 1? So dimension of rho r equal to dimension of rho divided by dimension of rho w, where dimensions of rho equal m l to the power minus 3. Dimension of rho equal, where dimension of rho equal m l to the power minus 3. That's why dimension of rho is ml to the power minus 3 divided by ml to the power minus 3. So finally we get the dimensions of rho r as 1. That means relative density rho r has no dimensions, or has no dimension. Dimensions of rho r is equal to 1. That means relative density has no dimensions. Number 19th quantity is refractive index. Refractive index. Now refractive index mu is the ratio of C and V. That means mu equals C by V, where the value of C equal 3 into 10 to the power 8 meter per second. The value of C equal 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second, and its 9-digit value is 299,792,458 meter per second. The exact value of speed of light in vacuum is C, which is 299,792,458 meter per second, which is the speed of light in vacuum. Which is the speed of light in vacuum. Which is the speed of light in vacuum. And that is the maximum value of speed of light. And V is the speed of light in a medium. V is the speed or velocity of light in any medium or in a medium. Therefore, dimension of mu equal dimension of C divided by dimension of V. Dimension of C divided by dimension of V equal dimension L t to the power minus 1 divided by L t to the power minus 1. Hence we get the dimension of refractive index mu equal 1. That means refractive index is a dimensionless physical quantity. Additional information in connection with the refractive index is what? We get a number of physical quantities which have no dimensions. That means angle theta, then displacement gradient, angle theta, displacement gradient, relative density, angle, displacement gradient, relative density, strain, any type of strain, refractive index, all are dimensionless quantities. Are dimensionless are dimensionless quantities. Dimensionless quantities. It should be quantities, not quantity. Angle theta has unit. Angle theta has unit, that is radian. Angle theta has unit, that is radian, but it is a dimensionless quantity, or it has no dimension. It has no dimension, no dimensions, which is an exception. That means theta has unit but no dimension.